Hi, everyone. My name is Jonathan Trung. I am the head of community at Codecademy. We are so lucky to have so many people worldwide joining us today. That said, last call out, last call. Let us know what city and country you're zooming in from and what you're studying at Academy. Today, we are joined by the folks at KNIME. For those that don't know, KNIME is an open source platform built to productionize data science from day one by a team with a strong scientific background. Today, it has a strong user community of more than 300,000 across all industries in over 60 countries. To represent KNIME, we have two folks, Scott Fincher, Senior Data Analyst at KNIME in Austin, Texas. He will be the main one driving. And then his wingman, Corey Wisinger, Workflow Lead in the great city and state of Minneapolis, Minnesota. So a few things about the event. They're going to introduce what KNIME is, as well as visual programming basics, a walkthrough on integrating Gen AI into your data workflows, and then present a hands-on use case. So enough of me talking. Scott, if you could introduce yourself and please take it away.
Yep. Hey, everybody. I'm Scott Fincher. As Jonathan mentioned, senior data scientist here at KNIME. Let's go ahead and get right into it. We're going to be talking about how we integrate Gen AI into our data workflows with visual programming. So my assumption is that most of you today are probably seeing KNIME for the first time. So we're going to have a little bit of an introduction about what KNIME is, how it works. I'll kind of walk you through the interface. After we've done that and you've got your bearings a little bit, we're going to talk about leveraging AI with LLMs in KNIME, and I'm actually going to build out for you a live example workflow around sentiment analysis so you can see exactly how that works. Time permitting, we'll get into agents in KNIME a little bit. I won't have time to do a live build with you for that, but I'll probably be able to walk through a workflow with you a little bit just to show you the approach there. And then we'll have a wrap up at the end, time for some of your questions. Going to be shooting for about 10 minutes to the top of the hour to save for questions. But of course, if you have questions along the way, as Jonathan mentioned, Corey, who's also data scientist at KNIME, is in the chat. So please feel free to type those in, and he may jump in and ask some of the more frequent or interesting ones live, and so we can hear from you guys that way. Okay, let's go ahead and get started. So I want to talk to you first about how KNIME works. So what is KNIME Analytics Platform? It's a tool to make sense of your data. So whether you're doing, straightforward data analysis, something maybe a little more sophisticated, data science, data engineering, we've got you covered because KNIME is a really wide-ranging tool in terms of its functionality. So we can load in the data, do the transformations, clean it up, build visualizations and reports, train models, integrate LLMs and AI into our workflows, all sorts of stuff that we can do. The two key things about it are that first, it's open source. You don't have to believe anything I say about KNIME. You can go check it out and even look at the code if you want to. And it's a visual programming paradigm. So we're going to be dragging and dropping nodes and connecting them together to build our workflows. There's no coding required unless you want to. And if you want to, we do have nodes that allow you to integrate Python and R, Java, and some other programming languages into what we do here. So having said that, a little bit about nomenclature, because I'm going to say some of these words over and over, and I want you to kind of understand what I mean. So anatomy of a KNIME workflow. The first thing that I'll be saying a lot is nodes. What's a node? So a node is one of these colored boxes that you see on the screen here. Each node performs some specific task. A node does one thing. So you can see here we have a whole bunch of nodes lined up, connected together. On the left-hand side, the CSV reader does exactly what you think it does. It reads a CSV file, sends that data into these yellow nodes in the middle, which are transformation nodes to do some simple filtering and deduplication. And then over on the right-hand side, we have a couple of visualizations that we're building. All of these nodes connected together, we call a workflow, right? And you can see each node has a couple things associated with it. There's a little traffic light that I'll talk to you a little bit about in the demo. And there's also annotations along the way, right? So we can, just like if we were writing code, you want to provide good comments for yourself or for other people who might use your workflow later. So a good habit to get into to provide those annotations. Now, something else that we'll see in the demo is something called a component. What's a component? Well, it's this little gray box in the middle of the screen, and it actually consists of several nodes. We can take a group of nodes and collapse them down into a component. Why would we want to do that? Well, For one thing, it makes our workflows less visually complex. We can kind of abstract the complexity away in places where that makes sense. Components also allow us to share functionality. So if I have a group of nodes that does a particular thing, and I need to do that over and over again, then it can be nice to create a component. It's like kind of creating my own custom node in a way that I can then use later or share with someone else on my team, so we don't have to reinvent the wheel. And then also components allow us to build custom, what we would call combined views, or that consist of several visualizations all at once. So you'll see some components in what I'm going to show you here in a little bit. Also within KNIME itself, we're going to be talking about LLMs and AI and how to use that with KNIME. KNIME also has its own, you know, we call it Kai, the KNIME AI within it that will help you do things in KNIME. So it can help you write code where that makes sense in certain Python nodes or expression nodes. It can also help you customize and configure visualizations, and it can suggest nodes to you. Like, you are often going to run into cases with KNIME where you know what it is you want to do, but you don't know the name of the node that you need, and Kai can help you find that. It can also build out for you simple workflows to get you started. So we might take a minute to be able to see how that works as well. Ultimately, there are over 4,000 nodes included with KNIME, which seems like a lot. um, and it is, but I want to reiterate or reinforce that you don't need to know all of these KNIME or know all of these nodes to be successful with KNIME, right? You just need to know the subset that makes sense for the type of task you're doing. Now, you will notice on this eye test of a slide, there's a color scheme. So on the left-hand side, we have a whole bunch of these orange nodes. Those are generally about getting data into KNIME, reading from, a local file, reading from a database, maybe from something in the cloud, in Google or AWS or someplace. Wherever your data lives, we've got a whole bunch of different reader nodes that will help you bring that into KNIME. Those are the orange nodes. The yellow nodes in the middle help us transform our data, do our, straightforward ETL processes on it, clean it up, maybe introduce a little bit of code where we need it, joining, filtering, partitioning, that sort of thing. The green nodes, which is the next one over, those are about training, testing, and validating models. In our case today, the green nodes we'll see will be a chat model prompter for connecting to AI. But you can also do things for classification, like build a classification model with XGBoost or something like that. Next, over there, we have the blue nodes, which are about visualization, create all sorts of different types of visualizations, and then combine those if you want to into a nice combined view, and display many of them at once. And on the right-hand side, we have the red nodes. That's when it's time to take data out of KNIME and send it somewhere else. Maybe it's to a database. Maybe you're going to create a report. Maybe you're just writing out somewhere else. That's where that happens. So just wanted to give you a general orientation about the color scheme. Okay, ultimately, what all are we trying to do here? The goal is to lower the code barrier. So I have a little bit of code that I had written on the left-hand side here in Python. This is actually inside a Python script node. If I wanted to do it in KNIME, it does the exact same thing, reading in some data from a CSV file, doing some filtering, doing a calculation, creating a pivot table. Regardless of how we do it, we end up in the same place, where the data is exactly the same. And actually, for this little example slide, I verified that it's exactly the same. So that's kind of the goal of what we're trying to do here. Okay, let me show you around KNIME itself. Slides are okay, but demo's better. So let me take a minute to do that. I'm going to flip over to KNIME Analytics Platform. If you haven't had a chance to download KNIME yet, I would encourage you to do that at some point today. Like I mentioned before, KNIME is open source. It's free to download and use. So you just download, put it on your local laptop, and off you go. The first time that you open KNIME, this is the welcome screen that you're going to see. Here in the middle, I have all of my different recently used workflows and components that I've been working on, along with some links to some other stuff here on the left-hand side, a local space where I've stored additional workflows, as well as connections to the KNIME Community Hub, which I'll talk about later. But to get started, I want to take one of these example workflows here at the top. If I click on this combine, clean, and summarize spreadsheet data, that's going to open up a workflow for me. Let me make this a little bit bigger so that it's easier for folks to see. So what's going on in this workflow? So we have these different nodes that I mentioned before, you'll notice when I hover over the nodes, I get a little interface here that shows up. This allows me to execute the nodes and also configure the nodes. So what does that mean? Well, executing means to run it, right? If I run this Excel reader, it's going to take the Excel file that I've pointed it at, read that data in. If I want to configure this node, tell it which Excel file to read, I can click on the gear, or I can just double click on the node. And when I do that, I get a interface that is specific to this node, right? The Excel reader does a particular task, so it has its own configuration dialog where I can, point to the file that I want to read in. I get a preview of it as it happens. If I were to click on a different node, for example, and configure it, it's a completely different configuration dialog, right? Because concatenation is doing something else. And so there's other settings that I would need to set. But the idea for all these different nodes is you configure them and you execute them. I had mentioned the traffic light before. Most of these traffic lights are set to yellow, which means they're awaiting execution. They've been configured in some way, but they need to be run. So what I could do is I can, in fact, go all the way down to the end here. If I run this bar chart node all the way on the right-hand side, it's going to run everything that's upstream of it that it needs to be able to execute. So that's kind of a nice feature. If I wanted to go back and reset everything, I have a reset button up here at the top. I can also reset nodes individually by clicking on this little back arrow. And when I do that, you can see that the traffic light goes back to yellow. So I can reset everything in the workflow by going up to the menu and clicking reset all, and then you'll see they all go back to yellow. Okay. I guess one other thing that's nice to point out, if I go back and run all of these again, if I were to click on any of these nodes at any particular point, now that it's been executed, I can see the state of the data at that point. What has happened to my data after I did some filtering from reading in this Excel file? I can see down here in the node monitor exactly what the state of my data is. And if I go downstream after concatenation, what does it look like now, right? What does it look like after I look at this value lookup? It gives me a nice way of being able to kind of zoom in at particular points in my workflow and do a little bit of QA. Is the node doing what I intended for it to do, right? Because we can make misconfigurations and whatnot. I want to make sure that I'm actually getting the results that I expect. And KNIME, because it saves the state at the execution of every node, is really helpful for digging in and making sure that things are happening the way you mean them to. Okay, I had mentioned before about components. What if I wanted to create a component? Again, what's a component? It's a collection of nodes, right? That I can then reuse later or share with someone else. If I select each of these three Excel reader nodes, right click and create a component out of them, then hey, I have this little gray box. This is my, I can rename it to whatever, Excel readers, maybe. You have to be able to spell. And then I can execute this. It's automatically created all of the necessary ports for me. These little black triangles are the ports. And then it's feeding that data downstream. If I go into this component, you can see that the nodes are still exactly what they were before. I didn't change the functionality or anything. I just grouped them together. So this is going to help me to make my workflow a little cleaner, potentially at the top level, abstract away some of that complexity. And again, if this is a particular component that I need to reuse over and over again, I can share it and reuse it kind of like a custom node and just drag and drop it into my future workflows. For now, I'm going to undo all of that and bring us back to where we were. Let me show you a little bit around the interface elsewhere besides, just the nodes themselves. I guess, well, another thing important to point out is we can also add annotations, right? So that's been done in this example workflow already, where we've drawn boxes around groups of nodes to kind of highlight how they function. We've added text here. We've added annotations for the individual nodes. Again, right, like writing good comments in your code. This is something you want to do. If I want to create an annotation at any point, I can just right click and then, this is my new annotation. Again, can't spell properly, but that's fixable. And, I could change the font sizes and all sorts of things, right? So really easy to create new annotations on the fly as you go, which you should do. Now, if I look over here on the left-hand side, you see these little tabs on the left-hand side of my screen. These are going to provide some additional functionality. So the first one here, the info tab, is where I can actually document what's going on in the workflow overall. I can add tags to it. This is nice for when I need to upload things to the community hub. Um, I can include a nice description of what I've done. Where do you get nodes, you might ask? Well, one of the places that you can get nodes is from the node repository. Over here on the left-hand side, I can go in and see that by default, they're organized by function. So, oh, okay, I need an Excel writer here maybe at the very end. I can drag that into my workflow, connect that at the point where it makes sense, double click to configure it and write out an Excel file, for example. Or, any of these different nodes, I could bring in new visualizations or train a new model or whatever it is that I need to do. All of those nodes are organized in the node repository over here. If I want a more compact view, I could switch over to the tree view and then dig through in this way. We also have over here the Explorer, which is this just allows me to organize my workflows and my data into folders so I can go and find things where I need to find them. We also have Kai over here. So I had mentioned the AI assistant before. You can see that I actually used this yesterday in a demo. What's the best node to use for creating a pivot table? Let's ask it this question again and just let Kai answer this for us. So it's looking at our documentation, it's looking at our answers provided on our forum and several other places to answer this question. It provides me with a couple of different nodes I could use, the pivot node and the DB pivot. I can actually drag these in just like I could from the node repository and start using them. And if I want more detail about how it arrived at this particular answer, I can click on additional resources and see links to existing workflows, documentation, topics on our forum if I really want to do a deep dive on that. So Kai's really nice to help orient you when you're new. Again, what's the node that I need to do the thing that I want to do? I don't know the name of it. Kai can help me find that. And then we also have the node monitor here. This is useful if we have errors, which we don't at the moment, but I'm sure we'll come across them when we're building our live workflow. So that's all I wanted to show you about the interface, just to kind of give you an idea of what's happening, because when I start building things live, none of this is going to be completely new to you at that point. Let me stop for just a second and see, Corey, are there any questions that we should answer about the intro part here?
Nothing about the intro so far. Just one question asking about local models. And
Okay,
we'll get into the LLMs a bit later. So
yeah, that's
if
coming
you're curious
next.
to get a hint on that answer, you can check the chat.
Okay.
Otherwise, stay tuned.
Cool. And then I noticed we just had a question come in actually that says, how hard is it? This is from Pete. How hard is it to build your own nodes? Is there a template to start with? What do you need to know for coding or building nodes? The answer to that is yes, you can build your own nodes. How hard is it? Probably, if for you guys that know a little bit of Python or Java, not that hard. We do provide an SDK and we provide examples if that's something that you want to do. You can create your own nodes. You can create your own groups of nodes called extensions and make those available to the wider community. And we have lots of folks that do that, actually. So good question. Okay, let me go ahead and switch back to our slides for a second. I'm going to close this back out. If you wanted to play around with that workflow that I just showed, again, it's going to be the top left example when you open KNIME for the first time. You can see exactly what I used. All right, back to slides for a moment. Check how we're doing on time. Okay, good. So let's talk a little bit about how we could use AI via LLMs in KNIME. So I just mentioned extensions, right? Extensions being a group of nodes. We at KNIME have written the AI extension to include a bunch of different nodes to help you integrate AI. So that extension consists of a whole bunch of different nodes. There are authenticators that allow us to connect to different resources. So on the open source side, we have Hugging Face, for example. On the closed source side, we have OpenAI and Azure. We also have nodes that allow you to train and connect to local LLM models that you may have available. Regardless of which resource, what type of LLM you connect to, with these orange nodes that you see here, the ones in green, the LLM prompter, the chat model prompter, the text embedder, and so on, those are used regardless of which flavor of AI you're connecting to in the first place. We also have the ability to create and reference vector stores of a few different flavors, as well as create agents, convert vector stores to tools, and so on. So lots of different functionality that we've built in as part of the extension. We're going to see some of these notes here in a minute. So there's a simple 3-step process to using API-based LLMs within KNIME. I won't show you how to use local LLMs within KNIME, but it's really similar, actually. You're just using a slightly different set of nodes to do it. So first thing you're going to do is authenticate. You need to provide your credentials to whatever service it is you've decided to use. Then you need to connect. You can say, I want to use this particular model at OpenAI, for example. This is what we're going to do, and tweak a couple of hyperparameters. And then ultimately prompt, right? Create the prompt, send it over to the LLM, get the response, and then do something with that. So authentication, I mentioned Hugging Face is open source and OpenAI is closed source. Both have these authenticators that you just provide your token, in the case of OpenAI, as a flow variable. And I'll show you exactly how we do that here in a minute. Once we connect, the connectors are going to have slightly different options, right? Because they have different models available. If we're using Hugging Face Hub, then maybe we'll want to use the Big Science / MTO large for whatever type of thing that we're doing. Or in our case today, we're going to use GPT 3.5 Turbo 16K, I think, for our sentiment analysis example. You can use 4.0 Mini. I mean, you can use whatever models that OpenAI makes available. It's just a drop down in this connector. You pick the one that you want. And then when we're tweaking the hyperparameters, usually that is, we're saying how many tokens do we want to get back? What's the temperature, right? How adventurous or conservative do we want the model to be in its responses? And then ultimately, a prompt, we're going to send some sort of the input to the LLM. In this case, we're going to use the LLM prompter for our example, which treats row by row inputs on a 1-by-1 basis. So this isn't like a chat model where it has memory. It's basically just doing one shots for each row in the data set. It's going to evaluate what's been presented to it. So in this example here in the middle, you work for a travel agency. You're supposed to evaluate customer reviews of hotels. Extract the text from this text, which we would then provide, and then classify the sentiment as positive, neutral, or negative. We're going to be doing something very similar to this, except with movie reviews, I think, or maybe not movie reviews. I don't remember. We'll see here in a second. We provide each of those to the LLM prompter in this bottom port. The triangle, I think I see somebody asking about ports. The triangle indicates data being passed in. This gray square indicates a model being passed in. So we just tell the LLM prompter, here's the model we want to use. Here's the data that we're going to pass in. It runs. We get our results. And then, probably have to clean it up a little bit. So those are the steps. One of the nice things, we're going to use something called the expression node, which is a way that we can write a little bit of code within KNIME, and we can use the Kai Copilot to generate an initial prompt template. So you can use AI to come up with a good prompt so that then we can ask AI something else, right? If you want to do that, that's available to you. Okay, so what does this look like in practice? This is a very simplified example. We'll see something a little more elaborate here in a second. I have some token, an API key. I pass it in with the credentials configuration node to the OpenAI authenticator, connect to OpenAI in this case, pick which model I want, pick my hyperparameters. I have some prompt that I've defined, and then that goes into the LLM prompter. Okay. Again, slides are fine, demo's better. So let's do a little bit of demo within KNIME. So I have, and I'll zoom in so that you can actually read what I'm doing here. I have kind of a blank workflow here. This is actually one that we've used in an exercise that we do in some of our hackathons that I'm going to build for you live. So that's why we have some of this text here that's describing what's going on. And I've got a few different nodes that I've left in that I won't bring in because it's got my credentials in there, for example, and it's got the tweets. So let's go ahead and get started. Now, what are we going to be doing here? Oh, you know what? I actually do want to give you a little bit more background before I start the demo. I just realized, let me briefly go through a little bit of this. So this is the workflow I'm going to build. The goal is to create a sentiment analysis application leveraging an LLM. I think I said something about movie reviews before. That's not right. That's a different hackathon. That's a different example. What we have here are tweets about 6 US airlines from a Kaggle data set. You may have seen this data set before if you've played around with sentiment analysis. It's a fairly common one. It has 14,000 customer tweets in it. We have, in this case, the tweets true labels. So we know, are they actually positive, negative, or neutral, which is nice because then we can, after we have the LLM make its prediction, then we can score and see how well the model performed. As you might imagine, people tend to tweet at airlines when they're upset or things are running late. So a lot of these are negative, but we'll go through the process of this anyway. So there's going to be 4 sections to this workflow. I won't go through all of them in the slides here. I'll just build it for you. But the first thing we're going to do is read in the text and prepare and clean that a little bit for our analysis. So we have some simple filtering that we need to do. And you can see here some of what the tweets are, right? Like, why is my flight 345 redirected? Or what's your phone number? I can't find who to call. Is this positive, neutral, or negative? The LLM is going to tell us. Then we're going to actually connect to the LLM. We're going to prompt the LLM with a custom crafted prompt and get the results. So that's what's happening in the second bit. The results that we get from the LLM need to be cleaned a little bit. So we will introduce a little bit of cleaning to do that I'll show you. And then ultimately, we're going to see not only how well the model performed, but we can also look at the mismatches or the incorrectly predicted results and see if there's anything about those that maybe we could tweak to make the model perform better next time. Okay, now, as I promised, we're actually going to do the demo part. Okay, so where are we starting here? Again, we have our airline tweets. I'm just bringing these in from a CSV file to start with. So I'm going to execute this, and you can see down here at the bottom of the screen, this file contains a whole bunch of stuff that we're actually not going to use. Tweet ID, which airline, the name of the user that's posting, timestamp, all that stuff is fine, but we're not going to use it for analysis. Mainly what we care about here ultimately are 2 things. We care about the text of the tweet itself, and we care about the label. These are pre-labeled, remember. We have the true, neutral, positive, or negative value. So a couple of fields here that we care about. So the first thing that I want to do is actually filter things down to just what I care about. So I'm going to use a couple of different column filters here. Now, I showed you before I can get nodes out of the node repository. So I can search for the column filter and drag it in like this, and then connect from port to port. You'll notice that the port types need to match for there to be a connection. So this first one, what I'm going to do is keep only the text of the tweet. So there's all these different fields I could keep, but I just want the text. I'm going to execute that. Did I get what I intend? I can see down here, yes, I've only got the text. And because I'm going to be a good boy, I'm going to add a comment here and say text only right underneath the node. Now I'm going to make a separate branch here, also using a column filter for reasons that will become obvious. I'm going to actually, instead of going to the node repository, I'm going to drag into empty space. And you can see this is another way that we can select nodes. So KNIME is now suggesting to me, based on what it knows about the CSV reader, hey, people often use a column filter or a concatenate or a joiner. Yes, I want to use a column filter, so I'll just drag that right in like that. Makes it a little bit easier. On this bottom branch, I am going to keep only the airline sentiment. And the reason I'm doing that is because I want to essentially set this aside so that I can join it up later after we've made predictions using the LLM and see how well our model has performed. So let's again be good stewards here and add a little comment. Okay, so just some simple reading in our data and a little bit of filtering. Now let's actually connect to the LLM. So I have this credentials configuration node with my OpenAI token that's already been pre-saved. That's all I have to provide. There's no username in this case, it's just the token. So I can execute that, and that's going to be provided as a flow variable. we don't have time to get into all the nuances of flow variables within KNIME, but just know this red port indicates a flow variable that we can pass to other nodes. And in fact, that's what we're going to do here, because I'm going to use an OpenAI authenticator and authenticate to OpenAI using this credentials flow variable that contains my token. There's some advanced settings here, what URL to point to, but I don't need that. I'm just going to click OK and go ahead and execute this node. Got the green light. Now I'm connected to OpenAI, but I haven't selected what model I want to use yet. So let's take and make over here an OpenAI chat model connector. And this is where we're going to specify the actual model that we want to use. So when I double click on this, it says GPT-4o mini. I don't actually need that. I could use GPT 3.5 Turbo 16K. That's fine. I don't need 200 tokens in this case, but as we'll see with the prompt, I could probably get by with 25 actually. Let's do 25. And then we'll leave the temperature set fairly low. I don't want the model hallucinating things or getting too adventurous on me. So we'll leave it set to the default of 0.2. Again, there's some other advanced settings here that you could use, but we're not going to in this case. All right. So now I am connected to, which one was this? ChatGPT 3.5 Turbo 16K. Okay. Now I'm going to bring in an LLM prompter. Now you'll notice that the traffic light here is red, and that's because the LLM prompter actually takes two sets of input, right? It takes the model itself, but then also the prompt. Well, we haven't built the prompt yet, so this is going to be red until we connect with a prompt. So let's go ahead and do that. To do it, let me back up just a little bit. So coming out of this top branch here where I have only my text, I'm going to filter things down a little. Why am I doing that? Well, if I look at the column filter, I can see that I have 14,640 tweets here. For the purposes of this demo, I won't classify that many. That's just take too long. So instead, let's do maybe 200, right? So we'll do row number less than or equal to 200. Execute that, and you can see now, if I go down here to the summary, now I've got 200 rows. Okay, great. A little bit smaller data set to work with. I still haven't built a prompt yet. So to do that, I'm going to use an expression node. So not one of the more common ones that's used here. So we have to type it in and search for it. Within the expression node, this is one of those spots where I can add in a little bit of code with KNIME. You can see we've given you an example here at the top to basically orient you with the syntax. Over on the left-hand side, I have all of the different values that are coming into this node that are available to me. So I've got the row number, row index, and row ID, none of which I care about in this case, but I do have the text, right, of my tweets, which I do care about. Now I'm going to get rid of this example, and I'm actually going to, this is in the interest of time, not type all of this in. Going to go over here where I have the prompt helpfully pre-typed in. Okay, so this is our prompt. What's actually going on here? We're basically just concatenating a bunch of text, right? We're defining for the LLM what it is we want to do. So the task here is sentiment classification, analyze and review text and classify it into positive, negative, or neutral sentiment. Here are the instructions, evaluate the provided review, blah, blah, blah. You guys can read it. It's not that exciting. We're just explicitly saying to the LLM, if this review expresses, for example, satisfaction, happiness, or positive emotions, classify it as positive, blah, blah, blah. Down here on line 14, this is where we actually pass in the text of each row that's coming in from the previous node, right? We have 200 different tweets, 200 different rows. So we're going to create 200 different prompts that are all pretty similar, except the text is going to be different. And so that's where we change the text each time. And then down here at the bottom, we say, hey, here's what I want you to tell me. I want you to tell me LLM sentiment classification, then it's positive, negative, or neutral, one of those three values. The column that I'm going to generate here, I'm just going to call prompt because that's nice. And then if I want to evaluate the first 10 rows to see what happens, I can click this little button, and then there is my first large prompt with the text embedded in it. I could also ask Kai here if I needed help, like I showed you in the slide, to be able to create this prompt. You can just type in and, have the LLM tell you how to prompt LLMs, right? We could do that too. So this all looks good to me. So I'm going to click OK. Execute this. So now I have these 200 different prompts. So remember, the LLM prompter is going to evaluate these on a line-by-line basis. Okay. We connect that to the LLM prompter. We're going to say, hey, look at the prompt column. That's what we want you to consider. Generate the response column, or generate a new column named response. And we could get that either in text format or in JSON. In this case, we're just going to have it be in simple text, and that's okay. So I'm going to let the LLM prompter run. It's going to take a second because it's got to, loop through all 200 of these essentially. And let's do a little bit of data cleaning downstream while we wait on that. So what are we doing next? Well, we're going to have another expression node here, actually, to tidy things up just a little bit. And again, in the interest of time and me not mangling the syntax, I'm going to copy in this one-liner to the expression node. What's this saying? It's saying, I want you to replace for me in the response column, anywhere it says sentiment classification : I want you to replace that with blank space. Essentially, just take it out, because we want to get this down to the just the very basics of positive, negative, or neutral, so that we can compare it to what we originally had in our true data set. So I'm going to leave that alone. LLM prompter is still thinking. After we do that cleaning, we're going to use something called the string cleaner here, which does exactly what you think it does. We're going to clean up not all of our columns here. I think we just want, actually, okay. Before I start building all this out without my columns in place, let's go back and look at the LLM prompter and see what it did, because it's done now. So we have this response now, sentiment classification: neutral, negative, and positive, right? So we want to get rid of this sentiment classification : every time. So we can use an expression node to do that. One thing that I forgot to do, I created a column called new column, which is not what I really want. Instead, what I would rather do is replace the response. And you can see here, okay, we've got something that's nice and clean. All right. Now, after we do the cleaning here, there's still a little bit more cleaning that needs to be done. That's where the string cleaner comes in. I'm going to clean up the response a little bit more to do two things. One is I want to remove punctuation, because I know that the LLM can actually include brackets in some of this, which I don't want. I'm also going to remove all leading and trailing white space, just in case that gets generated. So just a little bit of house cleaning there. And then let's do another column filter, so that we are going to keep only the response column and the text. I'm going to take the prompt out, because that's just a bunch of stuff that we don't need. Okay, what do I have here? After I've done the prompting, I have the text, I have the response. That's great. Now, you may remember that way back here, we set aside our true values, right, that we had from the original labeled data. Let's join that in. Let's join that with what we just predicted. And we're going to join based on the row ID. We're going to keep everything that matches. Good. So now what do we have? We have the response coming from the LLM, and we have the airline sentiment, which we are calling the true value. These are hopefully going to mostly agree, but in some cases we can see that they don't, where the LLM predicted a negative, and the true value is positive, right? So instead of me looking at all 200 of these, a quick way for me to assess how the model has performed would be to use something called a scorer node. So we can compare the results from the model with what is true. And when I do that, I get this little confusion matrix essentially. Everything that is on this diagonal here, 36, 48, 75, those are all correct predictions. So that's good. Everything that's not on that diagonal is somehow incorrect. And we can see that off the top here, we have an accuracy about 80% roughly. So this could be improved, right? Probably we could improve it with, maybe some changes to our temperature, maybe with a better prompt, right? There's some other things that we could do. Now, something else that we could check on, maybe we would like to do a little bit of a deeper dive about why we might think that the predictions were wrong. Okay, so I'm using a rule engine here to essentially set aside anything that is incorrect. So I'm going to say if the prediction from the previous node equals 0, set this aside, and then I could use a table view node to look at these in more detail. So this might give me an indicator of why is this, here's all the wrong answers, right? Why are they wrong? Well, the model doesn't know why it's wrong, but maybe I can look and see. You've added commercials to the experience. That's tacky, right? The model predicted that as negative, which I would agree with. Here it looks like our source of truth may actually be wrong, right? So I could go through where there's differences and try and figure out, is the model having trouble with sarcasm or irony? Is it getting tripped up by URLs or our emojis making things goofy, right? Maybe there's some additional filtering I need to do. Again, build a better prompt perhaps. These are all things that I could try to improve my results. Okay, how are we doing on time here? Woo, I gotta go fast. Okay, let me jump back from this workflow that I built for you to a few more slides here. So again, I mentioned, this isn't perfect, right? It was just simple and straightforward. We did it in just a few minutes, but it could be improved. So again, can the AI understand ironic statements? Maybe we should have used a vector store to enrich things a little bit. There's other approaches that we could take. Ultimately, though, what this allows us to do is efficient sentiment analysis on large data sets with pretty decent accuracy. If we did this the old school kind of text processing way, where we built these large sparse vector matrices with all of the different words in our corpus and then built prediction models for sentiment that way, those work, but they involve a lot more training. We need labeled data to make sure that they're working properly. In this case, we do have labeled data, but even if we didn't, we could feed things to the LLM and be pretty confident that we're going to get good results. So that's where we're at with this relatively simple example. Now, there's lots of other things that you could do in KNIME using these AI nodes. Oh, before I get to those, if you want to try out this workflow that I just built for you, you can go to the KNIME Community Hub. I have a little tiny URL here, tinyurl.com/cc-KNIME. You may want to put that in the chat, Corey. tinyurl.com/cc-KNIME. That will take you to a space on the KNIME Community Hub where, if we look at my web browser, here's the Codecademy webinar. You can go in and see this workflow that I just showed you. It comes with the data so that you can play around with it yourself. And it's also got this other example that I'm going to show you here very briefly. But anyway, check this out. This is free to download and explore just like KNIME is. Okay. So AI agents in KNIME, I don't have the time to go through with you how we approach agents necessarily in KNIME. That's something we would do in a workshop probably if we had a couple of hours together. But I did want to show you there's something beyond just simple LLM prompting that you can do. So I want to walk through for you just briefly an AMA or Ask Me Anything agent that we built about KNIME, the company, as opposed to the software, that has several tools embedded in it. We can build an agent that is going to choose what tools it needs in order to answer particular questions. So we're going to have tools that will allow the agent to retrieve employee information, customer company information, the interactions and tickets that have been available for individual customers, and then how we could maybe classify their sentiment, how they feel in interacting with us, right, as KNIME employees. So these are the tools that are available. Here is a slide that will mean nothing to you, so let me show you instead what this looks like in KNIME. So Again, I'm zoomed out pretty far here. Let me zoom in so that you guys can actually see what we might be doing here. So on the top of this workflow, again, this is agentic, right? We're going to, maybe I'll start in the middle. We're going to ask some question. Ask the AI agent a question. Who opened the last ticket for the Stark Industries customer? That's the example that I'm going to ask it here. So we ask that question. We're going to connect to OpenAI, just like we did before. In this case, we're connecting to, what is it? I think we're using GPT-4o Mini in this case with a much longer maximum response length. Why are we using that model? Because we need that for the chat model prompter downstream here. The chat model prompter is a little different from what we saw before, right? The chat model is going to have a memory, so to speak. It's going to be able to keep track of the conversation that's been had with it. It also will allow a definition of the tools that are available. So we can feed into it as an agent and say, here are the tools that you can use. And you can see them down here. We mentioned on the slide, the company information, the employee lookup, the user info, and information about support tickets. Each tool has a rather lengthy description associated with it that the agent can use to make his decision. Like, which tool do I need to use to answer this question? Again, what was the question? I already forgot. Who opened the last ticket for the Stark Industries customer? So it's going to probably need to look up the company information, and it's probably going to need to look up ticket information as well. But we're going to let the agent make that choice, right? We're not telling it what tools it has to use or in what order. The agent's just going to do that. Now, if I execute this, you'll notice that we put this chat model prompter behind a recursive loop. Why did we do that? Well, because it's going to need to step through recursively using these different tools to answer the question that's been posed to it. So the first thing it does in the first iteration of the loop, who opened the last ticket for the Stark Industries customer? I need to go find the company information tool and look that up. So that's what it's doing here. The next thing that it does is it figures out whether there's a tool for it to call at all, because there's a possibility, right, that it gets to the end, so to speak. It's answered the question that it needs to answer, and it needs to break out of the loop. This little part helps that define whether it will do that or not. But in this case, there is a tool it needs to call. And because there is one, it goes down here to the bottom over to this call workflow, and it executes a second workflow that we don't see. But that workflow is the tool. In this case, it's calling out to the tool about company information to get to find out what Stark Industries is, right? Now, it's done that. I'm going to go ahead and let it run through the rest of its recursive loop, because once it does that, it calls out for one tool. Now you can see it's actually executing here. It's calling another tool. Pretty soon it's going to get to the end. What we can do is we can see the series of steps that it took to answer the question. The human posed this question: who opened the last ticket for the Stark Industries customer? It determined what tool it needed to use. It then called that tool. Then it determined it needed to use another separate tool about support tickets. It then called that tool, and it then got the answer. And in fact, in this little component over here on the right-hand side, we get a nice visualization of the questions it asked internally and the tools that it accessed to be able to get us the response. And then ultimately the answer down here, the last ticket was opened by Tony Stark. The ticket is titled blah, blah, blah. It was created on thus and such a date, right? We didn't tell the agent to do any of that. The agent, based on the tools that we made available to it, it decided what it needed to call, in what order it needed to call it, and what was necessary to answer the question. So that's about as short as I can make it for a demo on Agentic AI. If this is something that is of interest to you, just know that you can also take a look at this workflow yourself. I'll call the slides back up. Here it is, right? This is the idea of the recursive loop. If the goal is reached, right? And then this history that we just saw. All of this is available, again, in that same link that we had before. I saw that Corey put it into the chat. You can go and download and play this one too. The caveat here is that you'll need your own OpenAI key to try it out, but I assume many of you already have that anyway. So cool. All right. We've got a few minutes for questions here. I hope we have some questions here at the end. Actually, let's pause for that right now before I get into the wrap up. Corey, was there anything from the chat that we should point out?
You got called out on one inefficiency already there, Scott. There's actually the filter option in the CSV reader, as Pete very astutely noticed, would be more efficient than reading the whole CSV in and using the column filter. But otherwise, I think a lot of the questions were around like local LLMs. Maybe I'll just answer that one in brief over here. So we got to the LLM prompter pretty early in your demo, and there was an OpenAI authenticator and a chat model selector where you authenticated and picked which ChatGPT model you wanted. Those two nodes are all that changes in that entire workflow if you want to use a local model. So I think I mentioned in the chat earlier, very, very similar if you're using a local model. Um, and yeah, a few questions around the colors, and we answered some of those. I don't think we'll want to dive too far into those, but maybe we just open up the chat now to any, final questions for us about KNIME, the agents, or otherwise.
Yeah, let's do that. And while you guys are typing in the chat, I will go over just a few more slides here in the wrap up. We'll take that opportunity. So um, in case this is the first time you've seen KNIME, or maybe it's not, right? Maybe you've seen it before and you're thinking, how can I learn a little bit more? Now it's time. Well, just like KNIME software is open source and free to use, we also have learning courses that are available that are, for the most part, free for you as well. The self-paced courses that you can access at knime.com/learning. You watch a video, you work on some workflows, you reinforce the concepts, right? And you do that all at your own pace. Those are completely free. If you decide that you would like to have a course taught, um, by Corey or me or some other data scientists on our team, you can sign up for those as well. Those have a nominal cost. It's usually something on the order of $50 or something. Um, Take a look at those courses. We have level 1 through level 4. Level 4 is highly specialized in a bunch of different areas, time series analysis, text processing, visualizations, right? You can really start to branch out once you get to level 4. If you have questions as you're using KNIME and building workflows, we have a really robust community at the forum.knime.com. A bunch of those guys just love working on workflows and helping you troubleshoot and can suggest all sorts of tips and tricks to you. So I would highly suggest that. I'm on the forum myself all the time. It's a great resource. If you're someone that prefers, to learn by watching videos, we have a whole YouTube channel that you could check out at KNIME TV that you can see there. And we have other print resources too. Our cheat sheets, we have a whole series of those available if you like to have, a nice big cheat sheet with different nodes on it sitting on your desk while you work. Or, maybe you'd like to read through some of our textbooks or use case examples. All of that is at KNIME Press. And I'll just reiterate again, all of that is free as well. So we like to give away stuff to make your life easier when you're using KNIME. A little bit more to add if you're deciding, cool, hey, I might like to take some of these courses. We do offer certification as well for each level. So L1 basic through L2 advanced, L3 and L4, those specialized courses that I mentioned. You can take the certification exam, get a badge, share it on your LinkedIn. And we have something going on right now that we just kicked off either early this week or late last week, the 90-day certification challenge, where if you want to sign up and go through all 4 levels in 90 days, we will cover the cost of the certifications for you. So even that will be free if you decide to do it. And we have a couple links for you here. I think they're also in the materials that we sent out for this webinar, and Corey may have put them in the chat as well. So lots of opportunities for you to check out KNIME, pick the area that's of the most interest to you and dive in and learn. And we know Codecademy is all about learning, so that's why we wanted to highlight that to you guys today. Okay, did we get any questions in the meantime during my last bit of spiel here?
One kind of question, I'll read it for you. Let's see, let me summarize. Basically, the question is, how long does it take to become productive in KNIME? Obviously, when we're doing a demo, it's, we already know what we're doing going into it. Scott, you and I have been using KNIME for a very long time at this point.
Right.
So that's also kind of cheating, if you will. But maybe some anecdotes, like when we have customers, it really depends on what you're doing. We have customers who will hit the ground and have huge return on investments day one. It really depends what your workflow is like today. If you're already like, if you've been coding in Python for decades, it might take you a little while to get up to the point where you're proficient enough with KNIME that you see a return. If you're trying to break into data analytics from like a spreadsheet background, then you might see a much quicker benefit off of this. But as somebody with a Python background myself, um, and I've been using KNIME for 7 years or so at this point, to give you some scope. I find it much faster to prototype and to deploy, especially deploy with KNIME. So maybe that
Yeah,
gives you a bit of background, but again, it really depends.
yeah, I think that's a good answer. I mean, I come from more of the R side of things, from the statistics background. So I was using R a lot before I used KNIME. But if you take our courses and get through, I would say the L2 level, which is really going to cover things like flow variables and looping, some things as programmers you guys are already conceptually you're going to get right away. If you can get through that L2 level, then you're going to be at a point where you can at least be productive to some degree. And that's probably, doing the courses a couple of weeks, and it's not like full-time learning, right? Just a couple of weeks of going through the materials, and you'll find yourself in a spot where I think you can get value right away. And then of course, beyond that, the sky's the limit. So let's see. Can I upload files to the LLM from KNIME, like sending it a table directly or a file using a link? If you use
Yeah, I
the
can answer that
Yeah,
one.
go for it, Corey.
So today, as in if I download KNIME at knime.com/download and do this right now, you would need to use our GET request node to hit the API external from the node. But with our version 5.5 release, that will be 2 weeks, July 2nd. This feature is coming with a new data type that we're going to introduce called um, a message data type, where you'll be able to embed things like images, for example, to send through the LLM prompter that was demoed straight to your LLM of choice. So, of course, that will require connection to a multimodal LLM, which most of the modern ones are. But yeah, so right now, today, need a GET request. July 2nd will be a feature of the node. Yes.
Yeah, and a lot of what I showed you guys actually about agents in 2 weeks is going to be somewhat outdated. We have a much more efficient approach that is coming. So, we'll be doing future webinars that demonstrate exactly how that works. But all the AI stuff within KNIME is in active development right now. So if you're in that space and using it, we're going to have exciting things coming on a regular basis. So, where do we find out about the agents webinar?
I would encourage you to go to knime.com/events and
Yep.
follow along from there. Uh, we've got a few events planned and more to be scheduled, so I would check there. And we've also got our KNIME TV YouTube channel where you might find recordings of presentations that we give at conferences or other events too.
Cool. I think we've covered just about everything. And Jonathan, I know we're at the top of the hour now.
Yes. Well, first off, thank you so much, Scott and Corey. I know that everyone is on mute, but just like in the chat, could we just like thank our guests for taking the time to put together this presentation, ask these amazing questions. They took an hour of their time just to give us this information and do an awesome demo. So thank you so much. We're If they have additional questions, right? Because I feel like people have questions after an event happens and pops into the brain. What's the best way for them to contact you?
I would say reach out on the forum. Like I mentioned, I myself am there every day, and if somebody asks a question about the webinar, I'll see it. I'm
Yep.
also personally, if you hit me up on LinkedIn or something, then I'm happy to answer questions that way too.
Okay, gotcha. Well, thanks for making yourself available. A common question that we get, and I already answered this in the chat, but this recording will be on Codecademy's YouTube channel. I will make that available within the week. Yeah, if there's anything else, please reach out. Otherwise, have a good rest of the week. Thank you again, KNIME, as well as Scott and Corey, for today's event. Really appreciate it.
Thanks,
Talk to y'all
Jonathan.
later. Bye.
Thanks. Bye-bye.